Hello, welcome to the pass of your HTTP request on Platform.sh, which is a session that was presented during the tech track of the Evolve partner event by Platform.sh in October of 2024. I'm Luca. I've been at Platform.sh for 6+ years. I used to do technical pre-sales, what we call solutions. But before Platform.sh, I used to be ops, so network and systems engineer. I love finding weird workarounds that are technically correct, which are the best kind of correct, as everyone knows. Yeah, let's jump right in. Today, we'll discuss the requests, the cache, and the headers, rate limiting, and what we count, the security layers that protect the origin from bad requests, and then we'll show you the many steps of a request from the user to your container on Platform.sh or Opson. So we'll start with the requests, the cache, and the headers. I call that a needle in many haystacks because, as we'll see, cache is not cache is not cache. So what's a cache? We have many types of caches, I should say. You probably are familiar with the application cache, which can be Redis, for example, hopefully not file system. You have the web server cache, you have the CDN/proxy cache, you have the browser cache, you have the DNS cache. What we'll mostly discuss today is the browser cache, the proxy/CDN cache. So I'll start with saying like what's in a response, right? So in a response you have headers, and everyone loves headers. I usually look at so many headers that I forget there's a body attached. But there you go. That's a request, a response. Sorry. And so you can see there's a bunch of headers that are interesting to figure out if a request has been cached, if it has not been cached. Maybe it will help you figure out why it has been cached or why it has not been cached. So for example, here's a cache trick. Am I getting cache here? And will I get cache here? Feel free to pause the video if you want to play along. And then let's just check the headers together. If not, so I have the laser pointer here. So you can see that there's a bunch of items that are probably interesting in like figuring out if I'm getting cache or not. I have the age of the request, which is at 0, so that's a big hint. The date, well, as mentioned, this was presented in October, so that's an old screenshot. You have Xcache, and you have 3 items, and Xcache hit 3 items as well. Something interesting here, the vary and the cache control. The cache control mentions no store, no cache, must revalidate, and max age at 0. We can figure out that there is no cache here, so spoilers. There is no cache here because you see the miss. So that means that even though at the application level we got a hit, so it means that the application got the request but did not have to revalidate and remake a whole response. At the CDN level, we still have misses. In this case, the CDN is Fastly, but usually CDNs are pretty good at showing you if a request has been cached or not in the response headers. So headers are always where you want to start. And then to the question, will I get cache on that request at some point? You might think that because you get like a no store, no cache, the answer is no, but the answer is maybe. In that case, the answer is yes. You will get cache if you try again. So this is the same request, just a few minutes later. You still see the Drupal cache that is hit because it is part of the response. So it has been cached as with the response, and You can see that the dates are different. So, it's been a few minutes, but the age has changed. The age is not at 0 anymore. So that's the number of hits that have been served on that object, I should say. But yeah, I have a hit here, meaning that yes, in the case of Fastly, they uh, they handle that as like, here's the data center that has handled the request. So you can see that I have two Dublin. This is not Dubai, and then a CDG, which is French, because that's where I'm located. This is the closest one for me, and I have a hit here. I'm still getting a no store no cache though, and this is because at the origin the request looks like this, and I will share with you at the end a means to check the request at the origin level. And yeah, at the origin, the request looks like this. So the origin, I'm saying that if we bypassed Fastly, here's what the request would look like. And you can see that the cache control has been modified somewhere in Fastly. But the important part here is the surrogate control and surrogate key. And surrogate control and surrogate key always take over from the cache control and also are stripped. So your users won't see that part of the response. And yeah, so because I have a surrogate control as max age 1800, it means that I will get an 1800 seconds worth of cache. And then the cache control that you see here inside the response is meant for the browser. So your browser will not cache the request, the response. So if you request it again, the browser will not keep using the same page it fetched. It is going to fetch the page again. This is very useful if you have like a store, for example, where you have like articles and you want to change the prices, for example. You want the cache in the CDN to be a thing, because you don't want like to have to calculate the page every time, to have to generate the page every time, which would be very CPU and especially database intensive. But at the same time, you want your users to see the update as soon as it happens, as soon as you clear the cache in the CDN. So that's why you would typically find that kind of setup, where there's CDN cache but not browser cache. What's in an HTTP request then? So in an HTTP request, not shown here, there's TLS stuff. So I'm going to make a small side on SNI because SNI is very important. SNI is basically the host header, and the host header is, well, here it's platform.sh, it would be your website. It is basically akin to the host header, but before it happens, just for the TLS stuff. So you could, for example, request, and this is not like something a browser would do, but this is something that you could do to test stuff. You could, for example, request a specific certificate from the web server or CDN using a specifically crafted request. And to do that, you would use SNIs. Inside the HTTP request, you also have the HTTP version that you support. Headers, because everyone loves headers, as mentioned before. And yeah, more headers that I'm not showing everything here. There's like a lot of headers. Something that's interesting to see here is that, like, have the host, you have an accept, which is important. You probably would have a cookie, which is not shown here, because you would spy on me. And then you have here a cache control and a Pragmano cache. So question for you, and again, please feel free to pause the video. If you were at the session, you already know the answer because it came very fast. Is this request going to request a cached version or a non-cached version at the CDN level? I hope you guessed right. this version, these headers are going to request any version. And even though I know it said no cache, it doesn't mean that the CDN has to respect that. And you should be thankful for that, because if the CDN had to accept someone that says, oh, by the way, I don't want any cache, then it would mean that the CDN would basically be useless against attacks, for example, of like many people that would like request, no, I don't want cache, I want like a fresh page from your origin, and then everyone requests that. That would be a big problem. This could still happen though, and you would be able to easily craft requests that would bypass the cache, or maybe find pages that don't have any cache. For example, search typically wouldn't have cache, so to fix that problem, you would use rate limiting. And rate limiting is saving you from being too successful. Basically, rate limiting, as opposed to the next steps that we'll talk about, the security layers. It is a security layer, but basically it's like, what if you got many good requests, right? Rate limiting doesn't handle bad requests. That's not the job of the rate limiting. It handles lots and lots of good requests. So it uses counters to do that. So it counts a bunch of things. And this is the included rate limit that you always have with Platform.sh. And when I say Platform.sh, I also include Opson, because Opson is powered by Platform.sh. So this is always included. We always count, for example, the number of open connections at the same time, the requests per, and then we have different values, requests per second, requests per minute, the number of TLS connections, because you can reuse connections if you open one. If you open like 10 TLS connections, maybe you're doing something sketchy. So rate limiting helps you control the flow of requests after the cache. But this was only the included one, and we also have the Fastly rate limiting, which is very flexible, because you can, for example, this is a real case I had of a customer that wanted to only rate limit for fours, and this is something you can do with the Fastly rate limiting that you cannot do with the default rate limiting. It is also more flexible in the sense that you can set your own request per minute. So you can really tailor the rate limiting on the website you have. Let's talk about security layers. I will talk about the firewall, the WAF, and also your application. So just to recap, a firewall is a network. It is kind of dumb. Not always, but usually the firewall is kind of dumb. It says like, oh, this is an IP I'm not allowed to allow, or the opposite, like this is an IP I have to allow and everything else should be denied. And same for the ports. So it is mostly a network thing. It's there to save you from thinking about your database being open to the internet. It is only open to your application, in part thanks to a firewall. And then you have the WAF, or Web Application Firewall. Even though they share the firewall term, it is basically a man in the middle that actually reads the requests before they reach the origin. So your user sends the request, something opens the request, checks the request for bad stuff TM. Like it can be like SQL injections, it can be weird parameters, stuff like that. And then if it senses that the request is bad, then it is going to deny the request. We always include a WAF on Platform.sh at the enterprise and elite level. But we also have an advanced WAF, which is the NG WAF by Signal Sciences. I will show you at the end. I have a map of where it stands. But again, it is it can be more flexible, it can be more powerful, and it can block like more things, usually a bit quicker. But your application matters as well. I'm talking about security layers. Your application should be one. Even though you have like all of these beforehand, your application will still get weird requests, even if they don't seem bad on the surface. An example I have, for example, is like someone that tries to reset a password, and then tries again, or not tries to reset, but tries to guess a password, like a brute force attack. Maybe the rate limiting is going to get it, but maybe not. The WAF is not going to do anything about it because it's just someone that tries a password, right? It just looks fine to me. It's like someone that is typing the wrong password. It happens. But your application should be aware of these things, and you should also consider your application as like part of the security layers. Remember that when you do things right, people won't be sure you've done anything at all. That's the problem with security. You always try to plan as much as you can, and then everything is blocked, so it is basically invisible. And that's the thing you want, right? The if you don't do everything right, then you get a breach, security breach. Your data is out, your website is defaced. But if you do everything right, well, the website just works. But this is because you've worked so much beforehand. So let's talk about the many stops of your request. Here's the schema. And so, yeah, it starts here. You're the application's user. And I'm using the Fastly example here because this is the one that most enterprise and elite customers will use because Fastly is included with Platform.sh. So you go through Fastly, the CDN. This is where rate limiting at the Fastly level would happen. And then you go through, and of course the cache. And then you go through signal senses if you've subscribed to the option, which is going to block bad requests, if any. Then you go through inside platform.sh, you go inside the region, you go inside the load balancers, which are going to make sure the request is correct, through can continue through the rate limiting, through the WAF. And then finally, it is going to land into your project, into your environment, to the web server that is then going to send that to your application, maybe applications if you have multi-app. So that's the path of your web request. That's quite a path. That's quite a bunch of steps. But this is barely noticeable. Well, I'm not going to, okay, I scratched the barely. It is not noticeable for users. And hopefully everything is cached at this first step anyways. So you're trying to avoid everything else as much as you can with cache. Let's talk about some debug tips and tricks. Your browser remembers a lot. To take the screenshots I took before of the browser, I had to clear caches and make sure that I had like no application data or cookies or stuff like that. Curl is by default not knowledgeable about anything, which is exactly what you want to debug stuff, right? You want to pretend that you're just a new user coming to the website, just clicking on the link, first link on Google because your website is the best. You click on the link and then you get on the website. What would the user see? Will they see a cached page? If yes, is that what you expect? If not, why? Is it what you expect as well? And so what I typically use to debug headers and caches and security stuff is curl dash, and that's an I, it's ixget, all capitalized. You only get the headers, but it is still a get request. Please do not send like a curl dash I, because curl dash I is only going to get a head request. And a head request might get a different response from any of the components than a GET request. And a GET request is what your user is going to do. So you want AX GET. In Firefox, for example, you can always, in the developer console, you can always right-click and then copy as curl. It is going to copy everything, including the headers, the cookies. It is very fancy and very useful. You can always check at the origin, and this is something I mentioned before. You should check at the origin if you have doubts. Like, if you wonder, is my request, like if you discovered with the previous thing that your request was cached and you weren't, you thought that it should not be cached, then check at the origin. Like, what are the headers that are sent by the origin? What's making the CDN react in that way? And on Platform.sh and on Upson, well, on Upson you would have to replace platform with Upson, but it can do this. I know it looks kind of, it's a bunch, but it is going to create a tunnel using SSH, so everything is encrypted, to the environment that you're aiming for. And again, if you want to adjust environments, you can -e or dash environment. And then it is going to allow you to just request on 8080, and then 8080 is going to be your site as the origin has it. And then you can always use curl --connect -2, and then double colon, and then where you want the request to be sent to. And then everything else, like the AXGET that I showed before, and then the normal domain and the normal things. This will show you everything that needs to be shown at the origin level, which is very useful. Another thing that I want to talk about is the vary header. I call it the most important header you aren't thinking about, because usually when you have a cache problem, it is, well, either you're sending the wrong headers or you're sending the wrong vary. Your application is going to typically send vary headers as like either a custom header, which is like not really recommended, but you could, a vary cookie, and then vary accept encoding. And all of these things mean that when checking if a request should be cached or not, in the CDN should check the contents of that header. So for example, if you have like a custom header in vary, then custom header, when you get a response from the origin, the CDN is going to check the contents of custom header. And then if it has seen that contents before, it is going to send the cached version. Well, no, the request, not the response, sorry. It is going to check the headers from the request and then generate the request from there. So custom header. I'm saying like be careful with vary cookie, because vary cookie can be a disaster for your website if you set cookies right away. Like if you have a PHP session or something that is set all the time, then it means that each user, each browser is going to get a different set of cache. Maybe that's what you want, but usually that's not. Like for example, your front page would not be cached. Well, it would be, but just like it would be cached for you, not for me, and then I would have to try again. So each user is going to get a different version, which is bad for your performance. A vary accept encoding is something that you would typically see, because then it's what your browser supports. So it makes sense that your website can be different or served differently depending on that header. But again, you can set anything you want. Just keep in mind that if it is too specific, like the cookie one, then you're going to basically disable the cache for your users, which is not what you want typically. The worst one, of course, is the user agent. And if you vary by user agent, then you basically break everything. Well, you break the cache for everyone, and that's very bad. So think about the vary header. It is going to save you a lot of time. When thinking about the cache, keep it simple. Never disable it completely. There's a good reason we have so many layers. And consider it as part of your application. Like, it is part of your application. Your application actually knows what the cache should be. It is actually generating the page and sending back headers that tell the CDN what the cache should be at the CDN level, at the browser level. It is part of your application. So try to think about it before starting and not like as a last day item, because then if it is a last day item, when you go live and you have cache problems, it's a very bad situation. Either you have too much cache and then your users will get like the pages from other users, or not enough cache and then your user will get nothing because then the infrastructure is undersized. And that's the end of the talk. Thank you very much for watching. If you want to share your feedback, please do so here. I don't know if this is still active, but this is still here. And as mentioned, if you want to learn more about Opson, and not just Opson, but subjects around Opson, please go to the Dev Center, devcenter.opson.com. Thank you for watching.